Hello, my name is Robert Mitchell, and today Electropages is here in Nuremberg, Embedded World 2024, and we are at the NeoCortec stand, and I am joined by Thomas. Thank you for having us today.
Thank you.
Now, before we jump into the hardware that you're going to show off today, just tell the audience who you are and what you do at NeoCortec.
Yeah, so my name is Thomas. I'm heading up NeoCortec. NeoCortec is specializing in wireless mesh network communication. Very low power, highly scalable, very suitable for smart commercial buildings.
Fantastic. So a few years ago, I think it was Electronica we saw you, or Embedded World. We still can't remember which one it was. But when we last saw you, you showed some pretty interesting stuff where you had sensors around the building taking measurements. So could you tell us what's changed since that time?
Yeah, absolutely. So at the time, you're absolutely right. We did showcase a sensor network at the exhibition. At the time, that sensor network was created by one of our student workers.
That's right.
Yeah. So that was very exciting, of course. What we did, inspired from that, you could argue, was that we say, okay, let's enable our customers such that they can, for themselves, create similar kind of proof of concept of a mesh network. But not only that, now we want to bring a full solution, integrating the sensors, integrating the batteries, integrating towards the gateway, and then into the cloud.
Yeah.
Because essentially, what we offer is only part of the solution, right? So when somebody wants to build an IoT system, it's not only about the sensor, it's not only about the wireless communication or the cloud connectivity or the application in the cloud. It's basically all of the above.
Yeah.
So what we did was we partnered up with MikroElektronika.
Fantastic, because we were talking to them earlier, and they're doing some great stuff at the moment. So I'm glad to see you're adopting the Microbus.
Actually, what they did was they launched in January this product here, which is a clickboard that features our modules. So for this show, what we thought, okay, here's a battery. That's the power source. Here's a microcontroller. So we click that in. It happens to have a Bluetooth receiver also, so we use that to host the application layer. The Bluetooth device we scan for, or with the Bluetooth receiver we use to scan for how many devices are within range. That will give us an estimate about how many people are here or within the range of the device. We want to create a local network, NeoMesh, so we click that one in. Then we thought, let's go ahead and measure air quality as well.
Blimey.
So we click that one in. This is a sensorium temperature, humidity, carbon dioxide.
Can I just quickly mention, these are extremely tiny.
Yeah, very small.
Very, very small.
Very small. Well, yeah, not so small when you put them like that, but this is a development platform.
Exactly. So, because if you're going to make your own IoT sensor from scratch, once you finish developing, that's the only size there. This tiny little can here is the only thing you will be using.
Yeah, exactly. So that becomes now the prototype, if you like, of a product concept. Now, of course, some software needs to be developed that can be handled through their development software also. Okay, so now that's the sensor. We installed that in the exhibition hall where we're in here. We actually, I think, some 35 devices, I think, between the hall 3, what we're in, and the hall 3A.
Yep.
So all of them are now meshed together with the NeoMesh low power network. All of them running off batteries. All of them on 868, fully autonomous, creating the network. In our cupboard here, we have a gateway on a Beagle board, which is also featuring the Microbus connector. So then we slotted our mesh network module onto the Beagle board, running a Linux-based open source software that we provide that establishes the cloud connectivity. Then, and this becomes a long story now, but then together with AVNet, we basically...
There's a lot of people coming in together this project, isn't it?
Yeah. But it just goes to show how complicated or how many disciplines are involved in creating an IoT solution. So essentially, AVNet's IoT Connect allows us to basically inject all the data what we are capturing here into an AWS-based cloud application. That we can then monitor up here. Everybody can get access and see the data.
I think I would just like to very quickly say to our audience that when we're talking about the mesh network, it was referred that we've got halls 3 and 3A with sensors. But if you saw how big Embedded World is, that's a massive distance because these halls are absolutely gigantic and it takes ages to go from one to the other. So the fact that you're able to have those sensors communicate over 2 halls is really impressive.
Yeah, and actually, if we wanted to, we could have covered the entire exhibition ground. It's just a matter of adding more devices. Then the network will expand and include the additional devices.
And this mesh network is intelligently determined by these devices as they're connected to it. So they determine how the messages should route and stuff.
Exactly. And it's a very scalable and let's say reliable system. Each device will try and connect with up to 6 other neighbors, so you have a lot of redundancy.
Yeah.
And actually, this environment here, you mentioned the scale of the halls, but also the number of people here,
Is
the number of
massive
exhibitors, and everybody is doing some sort of wireless communication. So a lot of noise.
Which also explains why the Wi-Fi here is so terrible.
Very horrible. Yeah.
Absolutely horrid.
If you take a look, the ceiling is made from metal.
Well,
the walls are made from metal.
Yep.
So it's
Reflecting
basically one big Faraday's cage that will do a lot of reflection. So from a radio perspective, it's a complete nightmare.
Absolutely.
Yeah.
And yet, despite all of that, your sensor network is still functioning.
Yes.
And that's what matters, I think.
That's what matters. Yeah. So that's what we are displaying here, and of course we are very excited to do it together with MikroElektronika and Avnet, because a lot of our customers, they want to create a full solution. What terminology, sensor to cloud is what we're talking about. But yeah, so that's what we're trying to show.
Fantastic. So obviously this platform using the MikroElektronika is going to allow engineers out there to prototype your parts much faster.
Much faster.
And so instead of being a 4-week project for designing the PCB, it's just slot.
Yeah.
Get straight to the programming.
I mean, essentially, we started this a couple of weeks ago. Jotted the things together, took the different software libraries and put them together. And of course, we're saying now we are measuring air quality. If you want to measure
humidity, maybe, for example,
light intensity, whatever, then you just slot one of those.
Slot another one in. So how would you see this kind of technology changing over the next sort of 10 years? That of what NeoCortec provides?
So I think the core of our technology will stay the same, the massive scalability, the low power consumption, but of course, parts of the, let's say, low power consumption comes from the hardware itself. So
of course.
So right now we are working across different SoCs. We are in TI, Scilabs, Nordic, Semtech. Basically, we can let's say integrate our stack on many different SoCs. So, and with the invention that they are bringing in better radios and things like that, we will of course leverage. And on our side, we try to take advantage of more memory space and things like that to be able to add more features.
And we talk about low power, but I think numbers are very, very important. So give us an idea, when you say low power, what kind of power are we talking about?
So power consumption depends on how much data you're trying to transmit, really, and how big networks that you're creating. But in an actual case that we got from somebody who is monitoring temperature in a building, such to optimize the energy consumption of that building, they are seeing some 22, 25 microamp average current consumption.
25 microamps?
Yeah.
It's quite low then.
So that gives you, fairly long. I mean, even on a few AA batteries, you will get many years of operation.
That's crazy. That's ridiculous. So you can have entire sensor networks that you don't have to maintain for a long period of time. Because, like you say, the power consumption is so low, it can just keep going.
Yeah, actually what happens is when you install such a network in a building, throughout those, let's say we have maybe somebody running 7, 8, 10 years on a battery. Throughout those many years of operation, many things will happen inside of that building. It gets reorganized. They install a new wall, people are moving around. So the wireless network will be exposed to a lot of different changes in the environment. So what we also offer is on our gateway software, we offer a tool that will monitor the network for certain parameters that you set up. Not only, let's say, battery level, but also network integrity in terms of how many neighbors do each device have and things like that. So that tool will monitor all of those parameters for you, and then it can create an alert if something happens throughout the
and that helps to keep these networks running for longer by giving people the tools needed to identify where the issues may be.
Exactly.
So it's really interesting to hear about the building with all the different sensors across it. But what other applications could I expect to see these NeoCortec solutions in?
Right. So we have some traction within smart farming, smart agriculture.
Of course, large out space.
Yeah.
Oh, right. So what kind of ranges are we talking between any two devices?
Not a lot actually, but we get the range from the multi-hopping aspect of the meshing.
Right, so it's sort of jumping along.
Yeah. So you need a certain density of devices.
Yeah.
And of course, a certain radio will give you a certain range.
Yeah.
But we have, as mentioned, we are operating on many different radio platforms. We even have an implementation using LoRa modulation to get.
I was about to say, because if you got LoRa, you got kilometers of range.
Yeah, but again, range will come at the cost of
Bandwidth.
increased current. Yeah.
And bandwidth as well. So you can't send as much data as you could if you were on something like Bluetooth or Wi-Fi.
Yeah.
And so in the case of agriculture, you might find that you have a whole bunch of these sensors with your AA batteries that can last for years. You plant them in the field, and that gives you your mesh network, so you can get all the data across the whole thing, but they're using each other to make sure that the data from the very end of the field gets right back to the farmhouse.
Exactly like what we have here. I mean, essentially the devices over in Hall 3A, if you go to the far end or just skip into Hall 3A, the devices over there, they cannot reach all the way to here with their radio. So they take advantage of the multi-hopping aspect of the mesh. And I have to say that the main thing for us is that all the devices are battery powered.
That's the most important.
Yeah, because you can get other networks that will do multi-hopping, but only the multi-hopping comes from mains power devices.
And I was about to say, this is the core issue, because with things like Wi-Fi, where you've got mesh networks, they all have to be plugged in. You can't have that on battery power. Sorry. So this thing is battery powered mesh networking.
Yeah, and even Zigbee, where you can have some devices that are battery powered, when you start to extend the coverage of the network by adding routing nodes, those are mains powered.
So what we're saying is that as you add more devices, which are all on battery powered, you find that because you've got more devices in the network, there are more ways to connect. So your solution is able to minimize that energy consumption when figuring out how to make that change.
Yes, exactly.
Fantastic.
Yeah.
So just before we wrap up this video, I've got one more question for you. If engineers out there who are watching this video who want to get involved with NeoCortec solutions, what would you recommend that they do?
Definitely recommend taking a look at the MikroE ecosystem of solutions. It's a very easy way to get started. This is available through regular distribution. Of course, our products, our modules are also available on DGKey, mouse, or RS, things like that, or places like that. So everything is accessible, but if it's about getting it going easily, then yeah, MikroE is
Well, thank you ever so much for taking the time to see us today.
Thank you.
And you heard it first, Mauser.